This is about the yield to maturity of a bond. I wanted you to see how this equation is set up. So I've got just an example here. Find the yield to maturity of the following bonds. We've got a 9-year, 8% coupon bond. The price is $1,105 and it makes annual payments. Now, what the yield to maturity is it's kind of the reverse of most of the problems we do. We've done a lot of problems where I tell you about the bond, what kind of coupon bond it is, and I tell you, okay, the rate is this much and you find the price. But in reality, the way it usually works is that the dealer is offering a price for the bond. So in this case, that would be the $1,105. So you know that if you buy this bond, you're going to have to pay $1,105 for it. Your question is, well, what rate of return does that represent? If I pay that much for the bond, what kind of rate of return can I expect to earn from that? And that is the yield to maturity, right? The definition of the yield to maturity. Okay, so what it really is the yield to maturity is found. We literally find it this way. There's no way to solve for it mathematically directly. We have to do it by guessing, a trial and error solution. So what we do is we say, well, let's see. I think that's going to be about 7%. Right, so we put in a guess for yield to maturity, and then we find the price of the bond based on that guess. So what I'm going to do is take the present value of each cash flow I expect from the bond. Notice it's an 8% coupon. I expect to receive $80 a year every year, and then in the 9th year, the bond will mature. It'll pay me the last coupon payment plus the par payment, and I'll get $1,080. But every year, I'm going to receive that. So to find the present value, I just divide by 1 plus the interest rate. Okay, and in this case, my initial rate is a guess. And I'll get that present value. I'm going to copy that formula down so that I take the present value of all of the cash flows. So there's the present value of each cash flow. I'm going to add them all up, and I'll get that price, $1,065.15. Right now, that's not enough. Right, that's the price is too low, so I could guess. Actually, that means the rate's too high because I need the price to be higher. So I could guess 6%. Well, 6% is too much, so I can just keep doing this, keep guessing until I get the price equal to $1,105. You can imagine doing this by hand was a real chore, but we literally used to do it that way. All right. However, the Excel goal seek function will do this for you, so I'm going to do that right now. I'm just going to say data, tab, what if analysis, goal seek. And I'm going to say, listen, I want you to set the cell here that's I-32, the price. I want that to be equal to 1,105. Hold on. Yeah, no, not this cell. I've got this cell, 1,105. But no, I want this cell, the price that I'm calculating, and I want that to be equal to 1,105. Right? So let me do that again. Data, what if analysis, goal seek. I'm setting this cell D31, to a value of 1,105 by changing the interest rate that I'm using to find the present value. Right? That's my guess of the yield to maturity. I click OK. And it doesn't take Excel long to go through that and say, okay, well, at an interest rate of 6.43%, if I use that interest rate to find all these present values, then that gets me a price of 1,105. Right? And that is defined as the yield to maturity of the bond. Right now, obviously, this is a kind of a tedious process. Because of that, the developers at Excel have written the code to do this in the rate function, but they still literally just guess. You can see one of the options here is guess. So you can tell it which guess to start at. Right? So it's just an iterative process. Its first guess by default is 10%. So it's going to start at 10% and keep guessing until it gets the answer. But you can do that with the rate function here. I'm going to put in 9. The payment is 80. The present value is 1,105. I have to make that negative because Excel has to know which way these cash flows are going. I pay $1,105 today, and in return I receive $80 a year for 9 years, and then at the end I receive $1,000. Right? Putting that in, You can see that gets me 6.4274, which should be pretty close to, it might be exactly the, yes, okay. So we did it this way by guessing. This way is the Excel rate function, but it does the same thing behind the curtain. It's guessing too, right? So that's that. Now, I've got here the yield to maturity is the rate you will earn if the following two things happen in the future. And yes, that's true. Notice we're assuming that this rate stays the same all the way through. That is, you know, the money we expect to receive 8 years from now, we're still using that interest rate to discount it as if the rate was just going to be the same for the next 9 years. We know that's not true, but it's the best guess we can come up with at the beginning. Right? It's just in bond investing, it makes sense to calculate this number because it does give us some information. But the yield to maturity for a bond is the rate you will earn only if the following two things happen in the future. And number one is you keep the bond until the end. In finance speak, we would say you hold the bond until it matures. Right? This is why it's called yield to maturity. Right? You keep the bond all 9 years and collect all the payments. Okay, and then number two is you reinvest all cash flows at the yield to maturity. Right? And what that means is that, you know, a year from now you're going to get this $80 and you're going to have to do something with it. Right now you don't just go spend it and you don't take it home and put it in the cash box. You reinvest it, right? And you don't know what interest rates are going to be next year when you reinvest that. You don't know. You might have a good guess, but you don't know what rates will be. And obviously, you know, 8 years from now, you have even less of an idea of what rates will be. Okay, so this works, right? You would earn exactly this rate of return if, when you receive all these cash flows, you're able to reinvest them at exactly that rate. Okay, and you know that's not going to be true. Right. So, you know, one thing we know about this yield to maturity is that's not what we're going to actually earn. Again, however, at time zero, when we're making the decision, it's as good a number as we can come up with. It sort of illustrates, based on the price we're paying for this bond, what kind of return can we expect to earn. Okay. All right. So there's yield to maturity. Now, let's see. I've got here, prove the concept by showing the cash you have for the bond investment and assuming both 1 and 2 happen. Yeah. So what I'm going to say is, okay, well, suppose I buy this bond for $1,105 and then I hold it until the end. So I keep it and I collect all the cash flows. And as I collect those cash flows, I reinvest them at the yield to maturity. So after 1 year, I'll collect that $80 and I'll put it in the bank and it's earning $80. And then over the next year, I'm going to assume that I'm earning the yield to maturity rate. So that $80 will sit in the bank and earn 6.4274%. And then at the end of the year, I'll collect the next $80 and add to it. Okay, and so you can see that after 2 years, I'll have not $160, right? Because that first 80 actually earned interest. I'll have a little more than that. And if you get the dollar signs right, you can just copy this formula down. I'm always saying, well, how much do I have? Reinvest it at the yield to maturity and add the next cash flow to it. And if I copy those down all the way to the end, I will end up with 1,935.73. Okay, and if I calculate my annualized rate of return here, that means, well, I ended up with this much money. The investment I had to make to get that money was that price. It took me 9 years to get it, so I'm going to raise it to the 1/9 power and subtract 1. And if I've done everything correctly, that should give me the yield to maturity. And it does. Okay, and then the other thing to consider is semi-annual payments. There's just, you just have to realize that, we do it this way. By definition, of YTM is an APR. Right, we'll talk about that here. So I'm going to do the same thing with semi-annual payments. Notice now I've got Instead of 9 payments of 40, I've got 18 payments. I'm sorry, instead of 9 payments of 80, I've got 18 payments of 40. It's just I get paid the same $80 a year, but I get paid every half year instead. So, but I'm going to do the same thing here. Actually, let me change this guess to 7% just to make the example realistic here. So I'm going to do the same thing here. I'm going to set this up to divide by the interest rate that I guess, but I have to divide by 2 here because yield to maturity is by definition an annual rate, and by definition it's an APR. Right? So 7% in a year, compounded twice a year, I would divide that by 2. And I'm going to raise that to that power. I also need to be sure I've got the dollar signs around my rate there, so that I can just copy this formula down. Right? So based on that, if I copy this formula down, I take the present value of each cash flow at that interest rate that I guessed, I'll get that price. And again, I'm looking for the price of 1,105. I'm going to use GoalSeek to do this for me. So data, what if analysis GoalSeek. I want to choose a rate so that my price in D105 turns out to be 1,105 by changing the YTM that I guess. And I'll go through there and I'll get that value there, 6.4443%, and that's fine. Again, that's a very illustrative of what's going on. Okay, it clearly shows what's happening here. It's kind of tedious. The rate function can do that for you. So if I use the rate function, now notice the number of periods now is 18. It's not 9. I think of it as 9 times 2, right? The bond's a 9-year bond, but it's paid twice a year. The payment is 80 divided by 2. Present value is minus 1,105. That's what I pay for it. I receive the other cash flows. I pay this one, so it's negative. Future value is 1,000. Right? And the rate function will return this to me. And now the rate function can only find the rate per period. And all it sees there is there's 18 periods, and you get paid $40 per period. And so it figures out the rate you earn per period. So since this is semi-annual payments, it's going to give me the rate per semi-annual period. So the answer, the yield to maturity, it's defined as an APR. We just take that number times 2, and that is the yield to maturity. Notice in my equation here, when I solved for this guess, I took whatever was in there and divided it by 2. Right? So if you solve yield to maturity on these semi-annual bonds, it will spit out the semi-annual rate for you. You have to multiply it times 2 to get the answer. All right, and then I've got this show this concept above, so I can do that again. I get $40 after 1 year. Everything's going to be invested. Again, it has to be invested at the semi-annual rate. So just to be clear, I'm going to take that, divide it by 2. Right, so I'm investing at the semi-annual rate, and I'm going to add the next cash flow. And so every time I say, well, how much did I have last time? Well, invested at the semi-annual rate, and then add the next cash flow. Okay, and I think I have the dollar signs in there correctly, so I can just copy that down, and that's how much I'll end up with. So if I calculate the semi-annual rate of return, well, I ended up with that based on an investment of 1,105. It took me 18 periods to get there. Semi-annual, subtract 1, and I get that number. And if I take that times 2 to calculate the APR, I'll get 6.44. All right, so this is just demonstrating the assumption you're making about the reinvestment rate in the future when you calculate the yield to maturity. All right, so that's it on yield to maturity. I'll leave it there.